All right, let's get into it. Today, we're going to crack open the very devices we use every single day. We're going to answer a really big question. How do these incredibly complex machines actually work?
I mean, really think about it. You click your mouse, you tap an icon on your phone, you type out a sentence, and this whole world of things just happens. But what's that first spark? What's the very first domino to fall that sets everything else in motion? Well, it's a lot simpler and honestly a lot cooler than you probably think.
And that's it. Seriously, at the absolute core of every single computer, every smartphone, every digital gadget you own is just this one idea. A giant collection of microscopic switches that are either on or off. That's the entire language of the machine. And if you get that, you've got the key to understanding everything else.
So how in the world do you get from a simple on-off switch to something that can, edit your photos or connect you with someone on the other side of the planet? It all comes down to building a language from those simple ones and zeros.
And that language is called binary. Every single letter you type, every color you see on your screen, every note of music you hear, it's all just a unique sequence of these ones and zeros. For instance, the letter A, to a computer, that's just 01000001. It's the universal alphabet for every piece of digital information out there.
You know, this really puts it in perspective. We humans, we operate in what's called base 10. We've got 10 digits, 0 through 9. But computers, they strip all that away to the bare essentials. Base 2, just 2 digits, 0 and 1. It's an incredibly simple and efficient system, and it's absolutely perfect for a machine that's built on nothing but on and off electrical switches.
And here's where computers start to, think. They combine those binary signals using these tiny little circuits called logic gates. So, an AND gate, it's like a really strict bouncer at a club. Both you and your friend have to have an ID to get in. An OR gate is a little more chill. Either one of you is enough. And the NOT gate, it just flips whatever you give it. Your computer has billions of these, making tiny decisions that build up into complex operations. It's wild.
Okay, so we've got billions of tiny switches making these simple yes or no decisions. But how do you get all of them to work together to do something useful, like run a program? What's the conductor of this massive digital orchestra? Well, that's the job of the operating system.
Now I know what you're thinking. What does an Einstein quote have to do with computers? Well, it's actually a perfect metaphor. Think of the computer's hardware, all the circuits and wires, as its knowledge. It's powerful for sure, but it's limited to what it's physically built to do. The operating system, though, that's the imagination. It's the brilliant software that takes that limited hardware and just orchestrates it into something that can do almost anything. Just look at this web of connections. This is such a great way to picture the insane complexity an operating system juggles every single second. It's the ultimate project manager, keeping track of your browser, your music, your keyboard, your screen, all at the exact same time without missing a beat. So while you're just clicking away, the OS is doing all this heavy lifting in the background. It's managing every program, making sure there's enough memory, keeping things secure, and making sure all your devices can actually talk to each other. It really is the unsung hero that makes your whole computer experience feel so seamless. Okay, so we have the logic and we have the manager. But how do we get into the conversation? How do we get our ideas into the machine and get the results back out? Well, that's where input and output devices come in. They're the translators between our world and the world of ones and zeros. And these ports, these are literally the physical doorways into your computer. Each one is a specialized connection point built for a specific job, whether it's a USB for your mouse, an HDMI for your monitor, or that Ethernet port for your internet connection.
Let's use printing as a perfect example of output. You've got the old-school impact printers. Remember those dot matrix ones that went screech, ka-chunk? They physically smacked a ribbon to make a mark. But the non-impact printers we use today, like laser and inkjet, are way more advanced. They translate digital data into these perfectly aimed sprays of ink or patterns of toner using things like heat and static electricity. It's pretty amazing.
So with all this data flying around, documents, pictures, songs, how does the computer keep it all straight? How does it know that one bunch of ones and zeros is a photo and another is a text document?
It all comes down to the file extension. You know, that little 3 or 4 letter code at the end of a file name like .jpg or .docx. That's not just for show, it's a crucial instruction. It's like a label that tells the operating system, hey, this is a picture, open it with a photo viewer. Or this is a document, open it with a word processor. And you see these every single day. Most of them are for data, documents, images, music. But then there's the .exe file. Now that one is different. That tells your computer this isn't just data to look at, this is a program, run it. It's this simple labeling system that keeps your entire digital life from turning into absolute chaos.
So far, everything we've talked about has been inside one computer. But let's be honest, the real magic, the thing that changed the world, is what happens when we connect billions of them together. Let's talk about the internet.
Well, before we had the internet we have today, there was ARPANET. It actually started way back in 1969 as a U.S. military project. The goal was to build a communication network that could survive a major attack, because it was decentralized. It started by connecting just 4 computers, but that core idea of sending data in little packets became the foundation for everything that came next.
And from those first 4 computers, we got this. The internet today is this mind-bogglingly complex ecosystem. It's not just one thing, right? It's the World Wide Web, it's email, it's streaming, it's online gaming. It's this whole universe of protocols and systems that somehow let all these different computers talk to each other like it's no big deal.
Now there's a flip side to all this amazing connectivity. Once we open the doors for everyone to communicate, we also open them for people with not so great intentions. And that brings us to our final topic, cybersecurity. So let's meet the usual suspects. A virus is like a bad piece of code that has to hitch a ride on a legitimate program to spread. A worm, though, is even sneakier. It can travel across networks all by itself. Ransomware is basically digital kidnapping. It locks up your files and demands money. And a Trojan horse, just like the myth, it's a nasty program that tricks you into letting it right through your front door by pretending to be something you want.
So how do you actually defend your digital castle? It really boils down to 3 simple steps. First, just be aware of what the threats are. Know what you're up against. Second, install a guard at the gate. That's your antivirus software, and it's your first line of defense. And third, and this is probably the most important, you have to be the vigilant watchman on the wall. Think before you click on a weird link or open a strange email attachment. A little bit of caution goes a long, long way.
And we'll end with this great quote from cybersecurity expert Gene Spafford. It's a little dark, but it's also kind of funny, and it makes a really crucial point. In a connected world, absolute security is basically impossible. The goal isn't to be totally unhackable, it's to be a difficult and prepared target. So, the next time you click, or type, or tap, what are you going to be thinking about?